Here we are, we've arrived. Assess 18, page 267 onwards. I'm just do 3 questions because, as you can see, Pythag, once you've got it, you've completely got it. Now, I like this question, question 2. There's a nice application here. It says, essentially, work out the perimeter of this quadrilateral. Okay, just add up all the sides. Here we go. 9 plus 6 plus 7 plus... I don't know what it is. I've got to work it out. But look. But look. If I join a line from B to D, I've got myself a crafty right angle triangle and another crafty right angle triangle. See, because look, the right angles have been given to me. Without that, it would have been impossible. Now look, this is Pythagoras. That's a right angle. This is the long side. If I can work out the long side using these 2 little sides, I know that and I know that, and that means I can work out the short side DC. Once I've got DC, I can add up the 4 sides and get the perimeter. Bit long, but let's do it. Let's call this something. X is good this time of year. So X is the long side. Let's do it here. So X squared equals 9 squared plus the other little one. 6 squared. We go 81 plus 36. We go, I don't know, let's add it up quickly. 81 add 36, 117. Let's get the square root of 117 and get our value for X. 10.8, I'm going to call it 10.816, 10.82, and that's centimeters. I'm going to write it in there so to show its positioning. So X equals 10.82. Now we're going to do that, take away that to get that. So what should we call this then? Let's just call this Y. Why not? So Y is a small side. So Y squared equals the big side squared, take away the smaller side squared. Now I know this was originally 117 before I square rooted it, so that's that, and take away 49, and let's just do that. 117 minus 49 gives me 68. Press the square root button on the 68 in a second and we'll get an answer. Root that, we've got 8, don't get glitchy now, 8.246. I'm going to call that 8.25 actually, and that's centimeters. So what is the perimeter? Working just up here, here's the perimeter. Distance around the edge, 9 plus 6 plus 7 plus 8.25. All together now. 9 plus 6 plus 7 plus 8.25. Bam! 30.25. I'm not happy to round it up too much. I'll leave it like that. 30.25 centimeters. Right. That question's done. Did I get it right? I hope I did. I don't see why I would have got it wrong. What they say? Yeah, they called it 30.25. They couldn't bear to round it off either. Okay, moving on. Doing right. This is question 3. An equilateral triangle, I mean it would be because it's 3 15s there. An equilateral triangle has sides of length 15 centimeters. Work out the perpendicular height of the triangle. In other words, this vertical height that cuts it right down the middle and makes a 90-degree angle with the base. So I'm going to call that H. Alright. So again, focusing on the right hand side only. 15 would be the hypotenuse of this triangle. H would be the small side. And this half base here would be half of 15, which is 7.5. Now we're going to work out the small side. Lots of space here. So the height squared equals the hypotenuse squared, the big one. Take away the half base squared. 15 15s are 225. That times that is around about 50-ish. So 7.5 times 7.5. Make it 56.25 then. Okay. 56.25. Let's do subtraction. Bam. 168.75. Now we hit that square root button like so, and we're going to get the height of that isosceles. So sorry, the equilateral triangle. So 168.75. rooted equals, syntax error, I should put the root first, right, root 168.75. Bam. Right, look at this, 12.99, it's approximately 13, and that one I will round up, definitely, 13 centimetres, thank you very much. That's what you're going to get. Now, turning over for the last question, and there it is. It's quite nice. It says a telegraph pole is kept in a vertical position by wires of length 10 metres. So that one's 10 metres, and this one is X metres. Oh, great. That are fixed to the ground. If they weren't, it would just like ping off, wouldn't it? Calculate the height H of the telegraph pole, that one, and the length X of the second wire. Well, A comes before B. Let's take the hint. Let's work out the H. What have we got? We've got the hypotenuse, 10. We've got the short side, 4.2. And the height of the pole, H. We're working out a small side. So here we go. Doing A first. H squared is 10 squared minus 4.2 squared. That's going to be roughly 100. And what's 4.2 squared? Right, 17.64. Subtract. I've got 82.36. To get H on its own, you square root that. Let's get the H value. Square root of 82.36 gives us 9.075, etc., etc. So the height is approximately 9.1 to the nearest metre. Happy enough with that. Now part B, got to work out this X. Well, I know H is going to be 9.1. I may well use 9. I don't know. See what I use. I might use this one as opposed to that one. See how it goes. Right. X. We're working out the big side, so we're going to add. We're going to add the 9.1 squared, and that's this one, and the 7.6 squared. 9.1 squared gives us 82.81, and 7.6 squared is 57.76, all together now. That gives us 140.57. Now we need to square root that to get the length of the wire X. Alright, so hit the square root button and equals, yep, 11.856, so 86. So I'm going to call that approximately 11.9 meters to 1 decimal place. So if I put here 1 dp, at least I'm justifying what I've done, and that's fine. Listen, that's the end of chapter 18. It's the end of the assess. It's the end of unit 3. It's the end of my GCSE videos for you. Look, I'm smiling. I'm just so tired I can't rejoice at the moment. Maybe after I've had a cup of tea and a little lie down, we'll feel good about it. As for you, you work flipping hard, because I've worked really, really hard for you. Okay, have fun.